All right, today we're going to start talking about Chapter 4. Section 4.1 is going to be matrix operations. So before we can talk about matrix operations, we should probably talk about what a matrix is. A matrix is a rectangular arrangement of numbers in rows and columns. You guys may have talked about matrices in the past. The plural form of matrix is matrices. So if you hear me saying that, that's what I'm talking about. This box right here in the middle of the screen that I have labeled A, that is a matrix. Just so that you guys know, this right here, this is what we call a row, and mix up my highlighter color here. This is what we call a column. So the way I keep these straight, I always think of columns on a house. They go up and down right in front of them. So if you ever see a building with columns, those are going up and down. So columns have to go up and down. Row, as you row across a lake or a pond, whatever, you're going from one side to the other. So rows will run side to side. I'm going to pick this 5, but any number within the matrix, this is called an entry. So the 6, the 2, the -1, the -2, the 0, and this 5 are all entries. I'm just picking one, and it's kind of away from everything else that we've talked about. So that's why I picked that one as entry. But if I talk about a specific entry, any number within your matrix is an entry. Then the last thing, when we talk about matrices, we talk about the dimensions of a matrix. So what we're talking about there is we describe these as our rows. We put an X and then the columns. The way that's said is rows by columns. So if we look at matrix A up above by our matrix definition, we can see that we have 2 rows going across. So that is going to be 2 rows by how many columns do we have going up and down? Well, I've got the 6 and the -2, the 2 and the 0, the -1 and the 5. So that is going to be 3 columns. I have 3 columns going up and down. So the dimensions of A are going to be 2 by 3. Then here's just a couple different types of matrices that you may see. A row matrix, there's only going to be one row. It could have as many columns as you want, but it's just going to be one row. The same way that a column matrix is just going to be a column. You could have as many rows as you want, but you're not going to have a column. You're not going to have more than one column. A square matrix, same number of rows and columns. This chapter, we're going to end up working with a lot of 2 by 2s and 3 by 3s. So that's what we're working with. Square matrices makes things a little easier sometimes. And then a 0 matrix, just as it says here, all entries are zeros. So those have their place too. You can't just take it away like you can when we have a variable with 0 in front of it. You've got to keep those zeros in there. So we use a 0 matrix. Matrices. They can be equal, just not surprising there. They're going to be equal if their dimensions are the same and the entries in corresponding positions are equal. So what that means is, obviously the dimensions have to be the same. If you're working with a square matrix, you're going to have, or you've got two of these actually, so you're going to have two matrices. You're going to have a 2 by 2, 3 by 3. They're both going to be 3 by 2s. Whatever those dimensions are, they have to be the same. And then entries in corresponding positions are equal. So if it's in the top left corner is the same in both matrices. Same as bottom left corner, all throughout your matrix. Each position has to be the same value. So if I look at this first set of matrices right here, I've got 5, 0, -4/4, and 3/4. And I want to know, is that equal to 5, 0, -1, 0.75? Well, obviously the 5 and the 0 are the same. First thing we check, really, are they the same size? We've got a 2 by 2 and a 2 by 2, so this works well. 2 by 2 and 2 by 2. So dimensions are the same. If I were to simplify -4/4, that would give me -1. Those are going to be the same. And 3/4, if I write it as a decimal, is 0.75. So we're going to say that these are equal. So really, it's got to be about almost identical. It has to be identical. That's how they're going to be equal. If I look at this next set here, I've got, again, a 2 by 2 and a 2 by 2. So dimensions are the same. And if I look at the top left corner, in both of them, I have -2, -2. That's good. Let's go to the top right corner. 6, 0. 0 and 6 are not equal. So just that one thing right there is going to cause these to be not equal. And then if you keep going, you'll see that 0 and 3 are not the same, and -3 and 1 are not the same. So these really are not equal very much at all. So that's what we're talking about when I say that they're equal. Now we want to start talking about adding and subtracting matrices. This really, most people don't find this too bad. So what we do is we look at this first one. I've got 2 column matrices. So is really just as simple as adding entry by entry. So 3 and 1 are in the same spot. So I'm going to add 3 plus 1, -4 and 0. Oh, not -40. -4 plus 0, and 7 minus 3. Then I just add all those up. I'm going to stay in my row matrix, so I'm going to get 4, -4, and 0. So not much to it, just really adding entry by entry. If we switch things up and we go to subtraction and we go to a 2 by 2. So this is a 3 by 1. This is a 3 by 1. Now we're dealing with 2 by 2 and a 2 by 2. Okay. So again, we just go entry by entry. So I'm going to take 8 minus 2, top left from the matrix on the left, top left from the matrix on the right. I'm going to go 4 minus 6, 3 minus, and be careful here, we're subtracting a negative 7, and 0 minus a negative 1. Then remember, when we're subtracting negatives, we're adding positives here. So I'm going to end up with a 8 minus 2, which is going to be 6. 4 minus 6 is going to be negative 2. 3 plus 7 is going to give me 10. And 0 plus 1 is going to give me 1. And we end up with another 2 by 2 matrix. So we've got that our matrix at the end should match the same size as the 2 matrices that we started adding and subtracting with to begin with. The last one I want to look at here is if I check my sizes again. This first one here, this is a 2 by 2, and my second one, I have 2 rows, 1 column. So if I'm going to add these, we would go term by term, but there's nothing for this 0 and this 4 to be added to. So these are not equal dimensions. So obviously the 2 by 2 has 1 more column than the 2 by 1, so we can't add these. So always be double checking those when you're adding and subtracting. Could be a way to get out of a little bit of work of trying to solve one problem or another. Otherwise, you can check these and make sure that you can add the 2 matrices that you were given. That's an easy way to check and see if you know what you're doing. The last thing is we're going to talk about multiplying by a scalar. A scalar is really just a number like this 3 in my first example here, and it's not a matrix. It's really just a number. All this is saying is that I'm going to take this 3 and I'm going to multiply everything in this matrix by it. So multiply, I always think of this like the distributive property. So that 3 is going to get distributed to the 2 and the 0 and the 4 and the 7. It's not going to change the size of the matrix. So we're multiplying 3 and 2, so I'm going to get 6. I'll write this out a little bit better for you guys. So 3 times 2. I'm going to take 3 times 4, 3 times 0, and 3 times 7. So multiply this out, you're going to get 6, 12, 0, 21. Put that back in my brackets and make my matrix. All right. Be careful with these. These work a lot like just regular number problems. So if you have this 2 multiplied by this first matrix here, that negative 2 is going to be our scalar. That is not saying the same thing as negative 2 with parentheses around all of this. If you have your parentheses, follow your order of operations. You're going to add the matrices, and then multiply that whatever matrix you get by that negative 2 scalar. But this one's just telling us that we are going to multiply that first scalar by negative 2. So distribute to all of our different entries. So I'm going to get negative 2 times 1, negative 2 times 0, and negative 2 times 4, and negative 2 times negative 2, negative 2 times 3, negative 2 times 5, And to that, I'm going to add that second matrix, 4, 6, negative 2, 5, negative 8, 6. So when I simplify this matrix here, I get negative 2, 0, negative 8, positive 4, negative 6, negative 10, plus 4, 6, negative 2, 5, negative 8, and 6. And then I just add my like terms, or my corresponding entries. So negative 2 plus 4 is going to give me a positive 2. 0 plus 6 is going to give me 6. Negative 8 plus negative 2 is going to give me a negative 10. Actually, that 4 should be negative, so this should be a positive 8. So positive 8 plus negative 2 is going to give me 6. And this should be a negative 4. Holy cows. Mistakes all over the place. Oh well. That's why we do this. So easy to make mistakes. Make sure you keep your signs right. I've told you guys from day one, that's usually my downfall. Then I'm going to add the second column in each of these. So 4 plus 5 is going to give me 9. Negative 6 plus negative 8 is going to give me negative 14. And negative 10 plus 6 is going to give me a negative 4. All right. That's all I've got for you guys today. So hopefully you learned something. We'll practice this in class. So let me know if you have questions. You guys know where to find the homework on my website. So go ahead and we will see you guys in class.